Hi there, and welcome to the 12th episode of our webinar series on Oracle database upgrades and migrations. The topic today is very large databases. How do we move those largest of your production systems, whether it's a data warehouse, an operational data store, or an OLTP system, from one server to another, one data center to another, or even migrate them across platform? My name is Roy Swanger, and I'm Vice President for Database Upgrade, Patching, and Utilities here at Oracle. You'll also be hearing today from Mike Dietrich, our distinguished product manager for database upgrades and migrations. And Mike, as you probably know, is based out of Munich, Germany. Also, Daniel Overby Hansen, based out of Denmark, focuses on cloud migrations and has spent a lot of time doing things like working with customers who want to move their databases to OCI or to other clouds. And Rodrigo Jorge, based out of Brazil, is another senior principal product manager with hands-on experience with customers, especially in MAA and security areas. You'll probably want to get the slides for this presentation after it's completed, because there are a lot of links to information sources like support notes, for example, on specific topics. And you can get those slides from Mike's blog at mikedietrichde.com. We also have an upcoming webinar, which is kind of related to moving very large databases, but it's very specific to regular data pump. And while you might not use data pump for 100 terabyte database, you will still find it very useful when you're migrating databases cross-Endian or making other changes such as implementing compression and encryption. So I encourage you to mark this date on your calendar in March and tune in for our webinar on a deep dive into data pump. And of course, if you haven't seen all of our previous webinars, there may be some topics there that interest you, whether it's auto upgrade or preserving performance after an upgrade, moving to the cloud, and so on. We have a wealth of information available to you in our online on-demand library. So with this kind of introduction out of the way, what I'd like to do now is hand you over to Mike Dietrich, and he'll get the presentation started.
Thank you, Roy. Let us start with a quick introduction into today's topic, the migration of very large databases. And the first question we have here is, what is very large? And it sounds trivial, but you know it from your own environments most likely. For one person, already 200 gigabytes are a large database, while for others, you would consider not even 10 terabytes as large. In our daily jobs, we see databases between whatever small size you can ever think of, up to petabyte-sized databases. The biggest one I've seen so far is in like more than 10 petabytes, and such databases exist. And this is clearly right now very, very large. But I remember when I started at Oracle a while ago, we had this list of very large databases. And by that time, something like 50 gigabytes was considered very, very large already. So what means large today can be very small tomorrow already. So it depends. It really depends. What is large? You decide what is large. And large databases often are not strictly based, especially in these days, on Linux systems already. We still have a lot of these databases still on big Endian platforms like AIX, Spark, HPUX. More and more get moved over to Linux. This is the industry trend, I would say. We see this all over the place, especially when you go to cloud. Cloud vendors typically operate everything in Linux environments. But the Endian format may also decide for you which migration techniques are available. And we'll discuss this later. So what means big Endian and little Endian? It's basically a very old story about how the byte is ordered, either increasing or decreasing addresses. And like you see here in the example, John in a big Endian platform is in the From the reading perspective, right order of the bits, while the little endian platforms have it in the reverse order. Speaking of big endian and little endian platforms, these are the platforms we have in the database world right now these days. And you have the big endians and the little endians, but we don't read them here. We basically can shrink this down to the most common platforms on the big endian side. It's AIX, it's HPUX Itanium, and it's Spark Solaris. While on the little endian side, we mainly speak about Linux, Windows, and Intel Solaris, even though Intel Solaris last release where it is available is Oracle Database 19C, but there are still Intel Solaris systems out there. In the database itself, you can find this mapping between platform ID, which will become very important later on when we speak about transportable tablespaces, and the platform name in $, transportable platform. And sometimes the names are a bit strangely written, but you have to stick exactly on these names when you need the platform name somewhere in the Oracle universe. What does that mean typically when we go very common scenario from a big Endianness platform to a little Endianness platform? So we have data or table spaces, and the table spaces, once they are moved over, need to be converted. So whenever we move something over, which is not a pure export, we need to do a conversion. And often this conversion happens then on the newer platform, because the newer platform most likely has also the faster storage, more space available, more compute power. That's a typical scenario, something we see very, very often. I've seen only one little Endianness to big Endianness migration in the past 2 years. Another question we need to answer here: are you upgrading? Or to be more precise, are you going to a higher release? Is your source on 11.204? And are you not just moving from the big Endianness platform to the little endian, but you also go directly into Oracle Database 19C, the release you should upgrade to? That's a question we need to answer. Then we need to understand your downtime requirements. The most common answer we receive when we ask about colleagues or customers is either as little as possible or close to zero. And then we have to ask again and say, what does it exactly mean? We would like to understand your SLA. And believe it or not, even when people say close to zero, I've received tons of answers. In one case, also like 24 hours. Because the customer was used to having a full week of outage for their previous migration 5 or 6 years ago. And the database is so big, so they said, hey, 24 hours, that's for us close to zero. We can do this on a Sunday when the business is down anyways and nobody's doing updates. So it really depends. But even if you approach somebody from Oracle or us directly, we need to understand, are you going to a new release? What are your exact downtime requirements? And also, another very important question these days, especially since we have free user-created pluggable databases included in all license agreements since 19C, are you going to Oracle multi-tenant as well, to the CDB architecture or not? You will see in the seminar, this makes a difference as well. So what is the best technique then? And people ask us and say, hey, Mike, my customer is migrating from AIX to Linux on this new brand new ExaCC. What is the best approach? We need to understand beforehand what the scenario looks like exactly. The questions we had on the slides before are the ones you need to ask internally as well for your projects. And then the best technique, it depends. Because there is no best technique usually. For a database upgrade in place, I can always tell you it's auto upgrade. No discussion on that. But if we do a migration of a very large database, there's no golden answer. First of all, we have to balance. And you may have seen that slide in previous seminars already, but it's still true. It hasn't changed since then. We need to balance between a simple solution, but also meeting the downtime requirements. And typically, the tighter your downtime requirements are, the more complex the solution gets, unfortunately. Here are the possible solutions. And one I will just wipe away from the slide right now. We don't want to discuss data pump here today because we will have soon in March a full 2-hour seminar just on data pump. So we won't cover that here today. But we will speak about RMAN, data guard, transportable tablespaces in combination with full transportable export-import, and as a potential zero or close to zero downtime solution, Oracle GoldenGate on top of each of them. This is our plan. And with this, I hand over now to Rodrigo, and Rodrigo will start discussing RMAN backups with you.
Thank you, Mike. Now let's see the first same-Endianness migration technique, which is RMAN. So RMAN is a very well-known method. Let's just take a look on the concept of it. So first you have your source database system. What you do in this system is you take a backup incremental level 0. With the incremental keyword here, you're going to prepare this backup set to receive incremental level 1 backups on top of it. So after you take your level 0 incremental backup, you move this backup to the target system and you restore the database backup there. Now that this backup is restored in the target system, you go back to your source system and you take another level 1 incremental backup this time. So now it's level 1, not level 0 anymore. And with a level 1 incremental backup, Oracle will only put in this backup set the blocks that changed since the latest level 0 or the latest level 1. It depends if you take a cumulative or a differential incremental backup. By default, Oracle will also take differential backup, meaning it's only gonna get the blocks changed since the latest level 1. After taking this level 1 backup, you move it to the target environment and you recover the database there using this backup. So you keep taking those incremental level 1 backups in a loop and apply them on the target system. Finally, when it comes to the downtime, you stop your source environment, you put it in mount or read-only mode, and you take a final level 1 incremental backup. You move it to the target environment and you recover that backup in the target system. Now, at this point in time, you have your source and target system at the exactly same point in time. Now, all you have to do is move your application and redirect the application connection to this new target environment. So RMAN is simply and easy to use. It's a well-known process. RMAN was released, if I'm not wrong, in Oracle 8i. So we have more than 20 years of RMAN already there. So it's pretty robust. It's already very stable. You can also use the existing backups. You don't need to start this process from scratch. You can take the backups you already have and just move them to the target environment. All you're gonna need is to take the final level 1 incremental backup. It's also independent of file system, or if you're using raw devices or ASM in the source or the target, it really doesn't matter. And you can also use it for some cross-platform capabilities, like moving from Windows to Linux, okay? So now seeing this process in a timeline, let's see how it works. So again, first you take the incremental level 0 database backup on the source database, you move it to the target environment and you restore it on the target database. Then, as I said, you keep taking the incremental level 1 database backups, move them to the target and recover the database on the target environment. You do this in a loop fashion until you have your downtime. So when you finally comes to our migration window, now you will take the final level 1 incremental backup on the source system. After you stop your source system, of course, you put it in mount or read-only mode. You take the final level 1 database backup and you recover the database on the target system. And then on that point in time, you have your source and target systems aligned at the same SCM. Finally, as the last step, you open your database on the target environment with reset logs. So if there are SQLnet connectivity between the source and target database, then most of the users will use DataGuard instead of RMAN Incremental Backups as a migration strategy. However, when migrating to a remote data center or maybe even to the cloud, you can end up in a situation where you don't have SQLnet connectivity between the source and target system. In that case, RMAN Incremental Backups are very useful. Also, when the source database release can't be installed on the target host, this is another good use case for this method. If you can install the same source database release on the target host, probably you will do so and set up a data guard in this case, as I said in the previous slide. Block change tracking or BCT is recommended to speed up your incremental backups. With BCT or block change tracking, Oracle will track all the blocks that changed in your data file since the latest level 1 backup. And then when you trigger a new level 1 incremental backup, Oracle will pick those blocks and put your backup set. So you won't need to do a full data file scan to take the blocks that changed since the latest level 1 backup. Also, if you use RMAN compression, this can significantly reduce the duration and the size of the backups. The size because you're going to compress them, and duration because as you will have much smaller backup sets. If you have I/O throttling in your tape driver or in your disk where you keep your backups, as you're writing less data to it, you're going to speed up the process. It's very recommended to secure your RMAN backups with encryption. Remember that when you move the backups from one system to the other during this in-transit migration, you need to be sure that those files can't be accessed by anyone. So the way to do this is either using tablespace encryption on the source system. So if you have TDE enabled there, your backups will have encrypted tablespace. So you don't need to care about encryption of the backups because this backups has already encrypted tablespaces. However, if you don't have TDE enabled on your source system, then it's important to use RMAN encryption to guarantee that nobody will be able to access the data of your backups. By default, each RMAN channel will back up a complete data file. This is good in cases where you have small size table spaces where the data file size will not be bigger than 32 gigabytes. However, when you have big file table spaces where a data file can be bigger than 1 terabyte, having one channel backupping a terabyte size data file is not a good strategy. So in that case, what you can do is use multi-section backups where you're going to split your data file into chunks. And each channel, then you can allocate a channel for each of those chunks, which will speed up your process. To recover the latest changes, use the incremental backup or archive lots. So in the concept animation that I showed just before, we used the incremental backups. However, if those incremental backups are taking a lot of time, or if you notice that you only generate like 3 archive lots since the latest incremental backup you took, then instead of creating a new incremental backup, you can simply move those archive lots to the target system and recover them. You don't need to take an extra incremental backup. And what about upgrade? So here in these examples, we showed how we migrate from one server to the other. However, with this strategy, we can also migrate and upgrade at the same time. Let's see how this works. So basically, to make this possible, the newer versions of RMAN can read and restore and recover older versions of backup sets created from older RMANs. So you can take a 11G database backup and restore and recover it using a 19C database software, okay? So let's see the concept of this. So let's go to the latest step where we already have the downtime. So here we stop our source system, and At that point that we take the latest incremental level 1 backup, we do the same here. So we take this latest incremental level 1 backup, we move it to the target host, we recover it, but now instead of opening our database in open reset logs mode, we add this upgrade clause. So with this upgrade clause, our database will be opened, and now I can run an upgrade process on top of it to put this database on the higher release. So we can run, let's say, auto upgrade or something, and after this database is upgraded, we finally redirect the accounts, the applications to connect on this new system. So let's see this again in a timeline. So first, again, we take the backup incremental level 0 in the source system, we move it to the target environment, and we restore it there. Now, before the migration window, before the downtime, first we run auto upgrade in analyze mode in our source environment to check all the reps that we need to perform before upgrading this system. So here in this example, we are breaking the auto upgrade in the 3 phases approach. So instead of running auto upgrade just with the deploy mode, we are breaking it in the analyze mode, in the fix up, and then finally in the upgrade mode. The first 2 steps we run in the source system, and the final one, which is the upgrade mode, we run in the target environment. So again, first we run the analyze mode to get all the list and to check if this database can be upgraded to our target host. So now when it comes to the downtime, to our migration window, we stop our connections on this system. We run again the analyze mode just to ensure that nothing is different since we do the latest analyze mode. And finally, we run the fix up mode. Now we are gonna fixing anything that's pending on the system to do the upgrade. Now we stop this database system, we put it in mount mode or in read-only mode, and we take this final incremental level 1 backup there, we move it to the started environment, we recover the database, we open it with reset logs and also with this upgrade clause, and finally, we run auto upgrade with the upgrade mode in the target environment. And that's it. That's how we use the RMAN to migrate and to upgrade our database on a single step. So now with Daniel, who will talk about PDB conversions.
Thanks, Rodrigo. But what about PDB conversion? Using RMAN Incremental Backup doesn't give you any added benefits when it comes to PDB conversion. As part of the downtime window, you need to convert the database into a PDB using the regular procedure, the non-CDB to PDB script. That requires additional downtime. If you also need to upgrade the database, it is strongly recommended that you first upgrade the database and then convert. Not only does the upgrade first approach offers you some better rollback capabilities, we also introduced a significant performance improvement in the 19.9 release. At first glance, it might seem appealing to use the method where you can clone a non-CDB database directly into a CDB over a database link. But we have not seen this method used with success for migrating very, very large databases. And the reason is simple, because this approach doesn't offer you any incremental apply, so you will have to suffer a lot of downtime while the entire database is being copied. The work that needs to be done on the source database, can you offload that to another system? And yes, you can with this approach, because you can use your standby databases to perform the backups and thus offloading the primary source database. Another option is simply to reuse the RMAN backups that you're probably already taking off the database. You can simply just fetch them from your storage system, your tape system, or wherever you have the backups, and put them on the target server and use those for recovery. The future target database, it has to be protected by DataGuard. With RMAN Incremental Backups, you can restore and recover the same backups to the future primary and the future standby database. And thus, the process of building the standby database inside the maintenance window will be a lot easier. So imagine this. the users are connected to the source database. You have your target system, future primary and future standby. And now, as a preparation for the migration, you build a level 0 backup, then you then restore on the future primary and the future standby database. Now you have downtime and you perform a level 1 incremental backup and put that on top of the future primary and the future standby as well. When you then open the target database, the primary database with reset logs, it'll start to begin generating its own archive logs. And you can then use those archive logs to recover the future standby database. Then you configure redo transport and redo apply, and now you have a working data guard environment with a primary and standby database. Now the users can connect to the new target system, and you are now fully protected by data guard from the very second that you complete the migration and allow the users to connect to the target system. What about a valid backup? My target database must have a valid backup before I go live on the new system. The backup pieces that are used for the migration can also be used for disaster recovery later on when you use RMAN Incremental Backups. When you prepared for the migration, you performed a level 0 backup and most likely multiple level 1 incremental backups. These are the yellow backups here, and you take them before the downtime window. The downtime window is the red part of the arrow, and in the downtime window, you perform the last level 1 incremental backup. Restore that onto the target system, and now the target database, the new database, will generate its own archive logs. At the same time, you also start a new level 0 backup of the target database. But what happens if a crash is introduced here, a corruption, for instance, before the level 0 has completed on the new target system? This is where you can use the migration pieces for your disaster recovery. Simply use the level 0 and level 1s from the migration, also the archive logs from the new system, and you can get to the point in time where before the crash. As part of the migration, a new incarnation was introduced in the database, but RMAN can, without any problems, recover beyond an incarnation change. And it works even if you also upgraded the database, because we learned previously that RMAN can restore and recover backup pieces from a previous version. So simply just start to restore and recover in the new release, and everything will be good to go. Unless you also convert it into a PDB. Following a PDB conversion, new backups are required of the data files that you're plugging in. Either you do a full level 0 backup of the container database, or at least do dedicated backups of the data files that you're plugging in. In Oracle Database 18c, the concept of pre-plugin backups was introduced that you can use for recovery of a PDB, but they don't cover all the scenarios that you might want to be protected from, and especially not if you have to do point-in-time restore of the container database. So our very clear recommendation is that you don't go live on the new system following a PDB conversion unless you have new backups of the data files from the PDB that you're plugging in. What about RAC? What if your target database must be a RAC database? That's not a problem with RMAN Incremental Backups, because RMAN and RAC are good friends. You can mix and match. You can go from RAC to RAC with RMAN Incremental Backups, or you can even go from single instance and into a RAC database. That is not a problem. If that's the case, I strongly recommend that you use shared storage on your RAC systems to the extent possible, because it will make the migration process a lot easier. I think that using shared storage is pretty much common practice anyway, but especially during a migration, this will make it easier for you. Because with shared storage, and if you have the backup pieces on shared storage, you can do multi-instance recovery, where all the instances in your RAC cluster can work together to make the restore and recovery faster on your target database. Also, when it comes to things like passwords files, SP files, and the TDE key store, if you have an encrypted database, if that is on shared storage, it will be a lot easier. Then what about the fallback plan? What if something happens during the migration and we need to go back? If you need to roll back, that is to go back to the source system before go live on the new system, that is very easy with this method because the source environment is completely untouched. We have left that preserved, so you can simply just start it up again, and the users can now connect to the source database while you figure out what the problem is. If you need to fall back, if something happens after go live on the target system, how do you go back to the source system? With RMAN Incremental Backup, you can simply just reverse the process and do level 0 and level 1 back to the original source system, and you should be good to go. Unless you also upgraded the database. If that is the case, you need to downgrade the database and then use RMAN Incremental Backups back to the original source system. Unless you are also in the case where you can install the higher release Oracle Home on the old system as well. If you also converted the database into a PDB, you are most likely looking into Datapump and GoldenGate if you need to fall back to the original system. In some situations, you might also use a downgrade and transportable tablespace, but that's a more advanced fallback scenario, which we covered in a previous webinar about fallback. That was it about RMAN Incremental Backup. Now, Roy will take you through DataGuard.
Okay, so thanks to Rodrigo and Daniel, you now know a lot about moving a database from one server to another with RMAN. And those incremental backups can be really handy for reducing the downtime of such a migration. But even with incremental backups, you might be talking tens of minutes, depending on how long it takes to take that incremental backup, apply it to the target, and so on. So you might want to look at DataGuard for a minimal downtime migration from one server to another. So DataGuard, the concept is pretty simple. What we want to do is we want to start with your primary database, which has users attached to it running whatever kind of transactions, data warehousing, OLTP, reporting transactions on that source database. While that's happening, we instantiate a target database. And the instantiation can be very simple. It could be an RMAN duplicate from active database for standby command that will build you a standby right over the network with one command. Or you could take your RMAN backups and restore them onto a new server and instantiate your standby that way. Either one works, and it may depend on how much network bandwidth you have, how large the database is, what's going to be the fastest way to instantiate that standby. Once the standby is in place, then we would configure the DataGuard redo, transport, and apply services so that we can synchronize your primary system, which still has users on it, remember, to your standby system. Once we have synchronized, then we can think about moving those users over to the new server. So this is when we're going to perform a DataGuard role switch, and the users will then point to the new server. And if you want, you could even reverse the redo apply and redo transport and make your old primary your new standby. Just remember the licensing for DataGuard if you're going to do this, because DataGuard itself does not have a separate license for this kind of functionality. We're not talking active DataGuard here. But if your standby is in operation for more than 10 calendar days in a year, then you have to license both the primary and the standby for the database and all the options. So this is a great solution for migrating a database from one server to another because it's simple, it's proven. Customers have been using this for 10, maybe even 20 years. I'm not sure how long, but well over a decade. And it provides you that minimal downtime migration for even the largest of databases and even going to geographically distant data centers. So it's a great solution in many cases for same-Endian migration. And notice I'm saying same-Endian there because it does not always have to be the same platform. There are some cross-platform capabilities of DataGuard that we're going to talk about. Okay, so at a high level, we've discussed DataGuard, but let's talk about some considerations there. The first one is that you need to have the same version and patch level of Oracle Home installed on the target that you had on the source. So that when you set up the standby and you're performing the redo apply, and then you go to activate the standby, you'll know that it's going to be operating the same way and that everything's compatible there. Now, if you're going cross-platform, you may not have an identical Oracle Home, of course. You can't take a Windows Oracle Home and just lay it down on a Linux server, but you would need to have the same patch level and the same patches installed on both sides. So let's take a look at a case where this can be a real consideration that you have to take in advance. A very common scenario right now is customers taking their 11.204 database and wanting to migrate it to a new server and upgrade to 19C. Well, if you're going to do that, consider the steps that are involved here. We have an 11.204 database, we've got a new server, and what if that new server is provisioned by default with Linux 8, which is pretty common because the sunset of Linux 7 is coming in just a couple of years. Well, to use DataGuard, we have to install 11.204 Oracle Home on that new server, but there's a catch here, because 11.204 is not certified on Linux 8, and it may not even work properly there. So what would you do in this case? You want to go to a Linux 8 server or a new server, but maybe you can't use Linux 8. Well, what you do is look at the platform certifications in My Oracle Support, and you could find that the sweet spot here is that 11.204 and 19C are both certified on Linux 7. So you'd install Linux 7 on that new server, use that to do the migration and even the upgrade, and then plan at some point in the next couple of years on migrating to Linux 8. So I mentioned that you have cross-platform capabilities here, so you do not need the same platform on your source and target host. And when we say platform, by the way, we're talking about kind of operating system families, Windows versus Linux. Different varieties of Linux are generally not an issue. You can go from Red Hat to Oracle Linux, for example, or vice versa. That's kind of a no-op there. But even with Windows and Linux, we do have the ability to move heterogeneous platforms as long as they're the same-Endianness. Both Windows and Linux are little endian platforms. So we've had customers who have moved sizable databases doing an RMAN duplicate for standby from Windows to Linux for, say, 70 terabytes, for example. So the Linux, the little endian or same-Endian migration using RMAN is detailed in this Moss note that you see here, and it will talk about the differences in capabilities depending on your source database version, whether it's 10.2, 11.2, 12.2. Of course, the capabilities improve as your source version advances. If we look in the instance characteristics, you can see what the platforms have in terms of endian characteristics. In this case, we have a list of the little endian platforms. That includes things like Solaris x86, a little used and now kind of sunsetted platform. So Solaris x86 users may be migrating to Linux. DataGuard's a great way to do that. Windows Server is also little endian, as is Linux x86. So basically, any x86 platform and then a few of the legacy platforms from Hewlett-Packard, from DEC, and so on were little endian. Another requirement for your DataGuard migration is to have a SQLnet connectivity directly from source to target. And I say directly because we can see cases where customers with very secure environments might have a situation like a primary database in one data center, a standby database in another data center without a direct connection, and they then put a DataGuard FarSync instance between the two to handle replication in kind of a DMZ zone, so that the databases aren't exposed in that DMZ zone. It's only redo being kind of forwarded from one database to another. Well, that works fine for DataGuard, and FarSync is a really nice feature for that kind of situation, but it's not good enough to do a direct migration, because for that switchover and roll switch and all that, you're going to want to have that SQLnet connectivity in place. RMAN compression is something that you might want to think about for reducing the network load when you're instantiating that initial standby database. Especially if you're doing RMAN backup and restore to instantiate it, the smaller the backups, the smaller the amount of data that you have to transfer over the network. And the general rule of thumb is that network is an order of magnitude slower than storage, and storage is an order of magnitude slower than memory. So in this case, we want to reduce the amount of data being moved over the slowest channel, which is your network. RMAN compression can help with that a lot. Now, the advanced forms of compression are generally part of the advanced compression option, but you could still use RMAN basic compression to reduce the size of your backups. You also want to think about encryption here, because security, of course, is paramount in most environments these days. And even if you have a secure network layer or secure subnets and so on, it is a really good idea to have multiple levels of security just in case the unthinkable happens and someone breaches that outer layer. So having TDE in place in your database is, of course, a good idea. That's the advanced security option. Or at the very least, if your source database is not encrypted, maybe you're moving to a situation where you're going to encrypt the database, you should encrypt your backups so that the data is encrypted not just at rest, but while in motion. So use RMAN encryption on your backups if you don't have TDE on your source database. Speaking of those backups, if you have a really big database, let's say you have a 200 terabyte database and you've got big file table spaces, you probably have some data files that are more than 10 terabytes in size. A big file table space can be up to 32 terabytes if you have an 8K block size. And that's a big file to move with one RMAN channel, because by default, RMAN's parallelism, what we have called RMAN channels, will use one channel per file in the database. If you have these really large table space data files, ones that get into multiple terabytes or even tens of terabytes in size, what you should do is use RMAN's multi-section backup capability that will break your table space data files when they're backed up into smaller sections so that you can use multiple channels to back up a single data file. I mentioned that the network is kind of the slow point of moving your data around, but what about redo? And the first thing we want to think about with redo, because remember, we have those users accessing the source database when we're setting up the standby, for example. So we're going to generate redo that has to be synchronized onto the standby. But how much redo do you generate? Well, that's something you're going to need to measure so that you know how much redo has to be shipped across the network and then applied on the other side. And it used to be that redo apply was a potential bottleneck, especially if you have a highly loaded rack database with earlier versions before multi-instance redo apply came into being. Now, it wasn't really a limiting factor in most cases, because as you can see here, the benchmarks that we had, we could easily keep up with 10, 15, even 50 terabytes of redo apply on a single node on a robust Exadata, for example. But if you have a super high-end system, then you might need to get into multi-instance redo apply, which is thankfully available now for you when you go into, say, 19C. And as you can see here, when you have a rack environment, such as an Exadata or even rack with commodity hardware, multi-instance redo apply scales nearly linearly across all the nodes in your rack now. So that's a big win when you're trying to synchronize a very active database. So if CPU and storage performance on your destination system isn't the limiting factor, what is? Well, it's the network. If you're going to move data across the network, you have to have the bandwidth to do it. So here's a quick back of the envelope calculation for you about how many gigabits per second you have to be able to move in order to have redo generation in terms of terabytes per day applied effectively onto your standby system. So the way to read this table is the number to the left of the slash, that's terabytes per day of generated redo. To the right of the slash, the yellow number, is gigabits per second of network connectivity. So in order to move 15 terabytes per day, you need a 2 gigabit connection to your standby system to make sure the redo will get there in time. Now, that's the minimum that you need. You should always plan for overhead and for extra utilization of that network, because otherwise, if you've got other databases on the network, you've got other jobs going on, like backing up to a NAS device or something like that, you're going to need that extra capacity in order to get the data where it needs to go in an effective time span. Finally, when it comes to redo, moving it over the network, Again, think about compression. Another part of the advanced compression option allows you to compress the redo when it is sent over the network. Now, you're not going to get a 5-to-1 or 4-to-1 compression ratio with redo, but we have measured anywhere from 35 to 65% reduction in redo volume if you compress your redo network traffic. So that can be another good way to make your migration as efficient as possible. So now I'm going to hand it over to Mike to talk about data guard migrations with upgrade in a bit more depth.
Thank you, Roy. But what if you want to do an upgrade? Not only using the physical standby as the migration vehicle, but you want to go to 19C as well. How do you do that? First, of course, you upgrade the standby, but you need to take into account that this adds downtime to the entire process, because after switch over, you still need to do the upgrade on your standby side. So how does this work? We have the application still running here on the 11204 production database, the yellow one. Our standby, the green one here, the target, is in sync. Now we get downtime because we will stop the application. Once the application is stopped, we do the final synchronization. And once the final sync has been completed, we decouple, we disconnect the standby. At this point, we can now activate the standby. And once the standby is activated, we can afterwards upgrade it to 19C. Once it's upgraded, we can now start the application on the previous standby side, which is now our new production database. Sounds simple, is no rocket science, very straightforward. This is how the process looks like. So on the source database, we call out upgrade with -mode analyze. And -mode analyze will now examine our source database. Then we will stop the application. This means we have downtime now. We flush the redo on the production side, make sure it's in the redo logs, and then we ensure that we have the final sync. Redo information is sent over on the target database. Then we stop the recovering by cancel. We recover the standby database finally, so now it consumes all the leftover information from the redos, and then we finish the managed recovery mode. Once this is finished, we can now activate the physical standby database, and once it's activated, we can open it, and at this point, we call auto upgrade for help and assistance, and auto upgrade will now repeat the analyze, do the fix-ups, then do the upgrade and all the post-upgrade changes. And then the database is upgraded, and we can start the application on our freshly upgraded target database. If you are going for less downtime than that, then please consider a transient logical standby database, either with the manual approach on a command line, or if you have an active data guard license, then with DBMS rolling. But what if you want also to convert to multi-tenant architecture? You remember you have 3 pluggable databases included. We want to do this conversion, and this is an even extra step. So you convert now manually after upgrade with the non-CDB to PDB after you plugged in your freshly upgraded non-CDB into a prepared CDB environment, or you prepare that beforehand and you let auto upgrade do the entire job, because then auto upgrade will upgrade your former standby and then plug it into the prepared CDB. Of course, you have to create that CDB where you plug it afterwards. Another idea with all the technique is, can we use a standby now to offload the work from the source database? Let's assume a situation where your source system has to remain completely untouched. The server can't get any additional load. We had such situations in the past quite often, where the server is so maxed out that you don't want to start anything on it. It will just cause trouble. So in this case, we use now a standby. So the standby is the initial offloading, and then from the standby, we create a final one. So we cascade. This is the idea. Also, when you target must become a data guard at this point, so you need a data guard for that, you can build up the future standby database already in advance. and connect to it also via cascading standby. So let me show you how that works. We have the production load on the source database, the yellow one, and we have set up already our migration vehicle, the physical standby database, the green one here. But for this physical standby database, we want a standby in place. So the redo apply is on, and with that, we create now the future standby. Because the dark greenish one will become my production system, and I want the standby for that already in place. So I create a future standby, I create redo apply, and this is a cascading standby. Now I will do what I did before. I stop the application, I do the final changes, I activate my standby, I optionally upgrade it if it's not upgraded already, but in this case here, we upgrade to 19C, and then I can start the production load. And at this point, when the production load is started, the standby is already in place. And just to emphasize here, this, in most cases, when we get involved in projects, is a key requirement. The standby for the future production environment has to be in place, because if that is not in place, we can't start the application. It needs to be there. Disaster recovery is so important here. Your target database must have a valid backup before we go live. Yes or no? Of course, you need that. So before go live, perform a level 0 backup of the target database. We could discuss here if the cascading standby, so the standby is in place right away, is enough already, because here you have a DR. I would say, yes, that's fine. But in all other cases where this is not in place, you must ensure before you go live that you have a complete level 0 backup at this point. And you can use that level 0 backup also across an upgrade. That works. We tried it. You can recover forward even across an upgrade. But the devil sometimes is in the detail here. When you do the migration to multi-tenant, to the CDB architecture, then that doesn't help you. So especially in these cases, you must account for time for that level 0 backup afterwards, once you migrate it into the CDB architecture, before you can go live. So following a PDB conversion, new backups of the data files are really required before go live. That's essential. Don't overlook this point. Anything special to consider when my target should become or is already a RAC environment? No, no problem here. Standby can be configured as a RAC database. That's simple, straightforward as well. Yeah, and how about fallback and rollbacks? If I use that technique, if something goes wrong, and we know all Murphy is somewhere around occasionally, how can we go backwards? So first thing here, rollback. So rollback means just ensuring for an issue happening during the process before we go live, before we have any changes on our new environment. That's simple here. The source is untouched. So, hey, I just start the application in the old environment, and there's no problem at all. But if I have no changes and no upgrade done here, I have changes in my target environment, how can I go backwards? That's also very straightforward, because it's standby. I switch over. So I go backwards via switch over. What if I have done an upgrade? Then we can downgrade. And we showed you how to downgrade in a standby environment in our previous seminar 11 for the fallback strategies. But what if you migrated now to multi-tenant and you want to go back? Unfortunately, in this case, Data Pump and GoldenGate are your friends, but there's no other way, because this is a migration after a migration, and this goes into a new database environment.
Thank you, Mike. Now let's talk about another migration technique, which is the transportable tablespaces. And for this one, we can even go cross-Endianness if you need. So let's start with the transportable tablespace concept. The first thing about transportable tablespaces is that it works in both ways, in the physical way and the logical way. For the physical way is how we move the data files. So the data files can be unplugged from the source system, copied to the target system, and plugged there. However, for the metadata, which are all your users or your objects, metadata like your procedures, your packages, all the privileges you have, all the jobs, etc., you move them in a logical way. So you create a dump file, we export them from the source system, and we import them on the target system. In a few slides, we will see this process working step by step. So imagine your table spaces. For the system table spaces, we don't move it again. We move the metadata in a logical way. So we export the metadata, which is the data that's your system table spaces, using data pump. While for your data table spaces, we copy the data files and possibly even convert them if you're growing cross-Endianness. The benefits of transportable table spaces is that first, it's Endianness independent. So you can go, let's say, from AIX, which runs in big Endian, to Oracle Cloud, which runs Oracle Linux, which are small Endianness. Or you can even go from Windows to Linux that are the same Endianness. You can use this method to go from a lower version to a higher version, like moving from 11.204 to 19C, and also to move from the non-multi-tenant architecture in a non-CDB architecture to a pluggable database. Okay, the transport and convert step of the transportable table spaces can happen in two ways. One, using RMAN, which will create a backup. You can move this backup to the target system, then you convert this backup to the Endianness of your target system, and you restore it. Or you can use DBMS file transfer to do these two steps in a single step in a flight conversion, okay? So the advantage of using DBMS file transfer is that you won't need double space in your target system to first store the backup set and then convert it. It's done in a single step. The downside of using DBMS file transfer is that the latest version of the PERL script that we have, which is version 4, does not support this method, only version 3. We are going to talk about the PERL script soon later in this session. So let's see an example of this transportable tablespace method working. So first, let's imagine this scenario where I have my source system running 12.102, and in my target system, I create a brand new 19C database in an empty pluggable PDB. So I have my table spaces here, and for this scenario, I'm also going cross-Endianness. So imagine that my source system maybe is running in AIX, and my target system is in Oracle Cloud, running in a DBAS system, which is Oracle Linux. So they have different Endianness format. The first thing I do is I take a level 0 image backup of my data table spaces, not of the system table spaces. So I take this level 0 image backup, I move it to the target system, I convert it, and I restore it. Now, what I can do is I can schedule and keep taking level 1 incremental backups of those data table spaces. And then I move those incremental backups to this target system, I convert, and I apply them on the top of the data files that are already restored. So I keep doing this in a loop, can be every hour, can be every 6 hours, can be every day, depends on the workload you have. So you can schedule it to happen. And finally, after taking several level 1 incremental backups, when it comes to the migration window, you put your source data files in read-only mode for the data table spaces, not for the system table spaces. So you put it in read-only mode, then you take a final level 1 incremental backup. This is very similar with what we see in the RMAN strategy. We take this final level 1 incremental backup, we convert and we recover the data files in the target environment with this backup. And at this point, we have them in the same SCM. They are synced. They are equal, but in different Endianness. Now, finally, what we do is we do a full transportable export in the source system, and we import it on the target system. When we do the impdp for transportable, where we do specify the transportable data files, at this point in time, our data files are plugged in the target system, and the metadata is imported as well. So now we have our database ready in the target system. For EBS, we have a Moz note that explains step by step. So if you want to use this strategy with EBS, we do support it. All you need to do is follow this My Oracle support note to see how it works. So let's take a look on the checklist before you use this method for your huge databases migrations. First thing, the requirements in the target database. The compatible in the target system must be the same or higher. So you cannot use this method to go to a lower release or a lower compatible. You can only use this to go to the same or higher release and also with the compatible. Regarding the short set, we always recommend you to be at the same short set and national short set. For time zones and time zone file version, we also recommend you to have the same or higher ones. You can have lower ones only if you don't have a timestamp with local time zone in your database. Now talking about pluggable databases. Imagine you are moving from a database which has a short set as ASCII, and now you are moving to a higher release in a pluggable database architecture. Should you create your CDB as ASCII as the short set in the starter system? No, don't do that. We don't recommend this approach, because what we recommend you to do since the 12.2 release is to have your CDB in AL32 UTF-8 short set. And why? Because when you have your CDB in this short set, you can have the pluggable databases in any short set. However, when you create a brand new pluggable database in the target CDB to receive your transportable tablespaces, when you create it in a CDB that has AL32 UTF-8, the PDB will have the same short set. So in this case, what we recommend you to do to have a PDB in the same short set as the source system is to create a temporary CDB with the short set of your source system. Then you create a pluggable database in that short set. And finally, you move this pluggable database from this temporary CDB that you created in that special short set to your final PDB, which is your production CDB that's going to receive the transportable tablespaces from the source system. Okay? Regarding the time zone file, if the source and target database time zone file versions don't match, the tables which has timestamp with time zone, they will be skipped. And what you can do is you can import them separately afterwards using data pump. Regarding block change tracking, we strongly recommend you to enable BCT. And the reason why we recommend you to enable it is because your backups, the level 1 incremental backups, will be much faster. As I said before, for RMAN, for the RMAN strategy, when you have block change tracking enabled, Oracle database won't do a full scan on your data files to identify the blocks that changed since the latest level 1 or level 0. What it's gonna do, it's gonna keep a track of everything that changed in a separate file. And when you run your incremental level 1 backup, it's gonna pick those blocks and put your backup set. So this is gonna be much faster. Regarding the conversion, we recommend you to convert usually on the target system, because usually the target system is a newer system and the conversion will be much faster, especially because your target system is being prepared and you don't have any production workload running usually in your target system, while your source system is still with your production running on it. Use the PERL scripts to do the conversion. The PERL scripts can do this for you. And the requirements you have is Enterprise Edition if you are on premises or Exadata. And if you are in the cloud, you must use Enterprise Edition Extreme Support, Extreme Performance that is available on the DBCS solutions. Now talking about encryption. Unfortunately, tablespace encryption is not supported when you are going cross-Endianness. The reason for that is that RMAN doesn't know how to convert from big endian to little endian or the opposite while you have your tablespaces encrypted. So if you're going to the same-Endianness, this is okay. But if you're going cross-Endianness, then you need to, before doing this conversion, you need to decrypt before migrating it, and then you can encrypt back after you are in your target environment. Remember that since 12.201, you can encrypt and decrypt in an online way. You don't need to stop your system or stop your production workload to do an encryption or decryption of your data files. And finally, the PERL script. The PERL script that automates all those steps for you, they are available in this My Oracle support note 2471245.1. Downloaded there, you have also all the instructions contained in this support note. The requirement to use this automation is the source system must be at least 10.203, and the target system must be at least 11.204. So what are the best practices for this method to work? First thing, you need to test it, and test it a lot. Create some lab environments, try it on a pre-prod environment or in a dev environment. Don't go straight to the production. First, test this in other environments before trying it in your production environment. Also, whenever possible, automate it. I already migrated a lot of databases using this method, and I always create a shell script with all the steps to be executed automatically for me. So all I need to do is call that shell script. I don't need to do step by step, especially while I'm doing the level 1 incremental loop. When I take the level 1 backup on the source system, I move this backup to the target environment and apply there. So I automate it so I don't need to keep running those incremental steps all the time. Save all the logs for later check. In case you have any issues, you can see on the logs if you had any troubles there. And also, in case of failure or rollback, create a cleanup procedure, and then you can repeat your tests multiple times. Don't forget to put your source environment offline after you do the migration. So with this, you will avoid any case of split brain, where you accidentally have some leftover applications that connect in the old system. What about a fallback? Imagine you try this method, it works for your production environment, but after some time, you realize that you have some major issue and you want to go back to the previous release you had. So if you had the problems before the go live, meaning during the validation process or during the upgrade process, you realize that you had some troubles, then you can simply roll back to your original system, which is kept preserved and untouched. You simply need to put it back in redirect mode and direct your applications to connect there. Now, if the problem happens in a post-go live, meaning imagine after 7 days of running in this new target system, you realize that you have some issues, then you can reverse the process. You can create all the process in the opposite way. However, you can do that if you also use these transportable tablespaces to go to a higher release. This only works if you went to the same release. If you went to a higher release, then the only method you can use to do a fallback is either Datapump or GoldenGate. Now with Mike, who will show you the step-by-step of the PERL script to perform this HTTS strategy.
Now a quick introduction into the process using the PERL scripts. So a step-by-step approach. We divided this in 6 phases. We have the setup phase, where we put everything in place. Then the prepare and level 0 phase. Afterwards, we roll forward with incremental backups. Then we get downtime before phase 4, because phase 4 is then the final incremental backup. In the phase 5, we do the transport, and in phase 6, we clean up. So let us start here with the creation of our target environment. And this can be a database or a pluggable database, doesn't matter. As you remember, compatible, equal, or higher than the source, identical database character sets, identical national character sets, identical time zone versions, and identical database time zone settings. And with that, setup, we can start. What we need is we need the v4, that's version 4 PERL scripts for transportable tablespaces from this My Oracle support node. So it's a zip file at the end of the node. You download that zip file, you unzip it, and you will find those 7 files then on disk. What do? I have 2 options. First of all, the standard method supported by these scripts is doing a backup from my tablespaces. And when I use the backup approach, I need staging space because backup and restore and convert can't happen in one pass. So first up is the backup. The backup gets written into a staging space, and from there we grab it, we restore it, and while we restore it, we convert it as well. So it's a 2-phase approach, and always remember that staging space. In the PERL script dictation or notation, we'll use XTD driver PL -- backup and -- restore for these actions. The other method where we officially don't support it anymore with the v4 scripts, even though it still works, it's still in the code, but you don't get official support, and sometimes it can be smoother and easier for you, is the DBMS file transfer method. So in this case, we use XTD driver PL -S and G, so for the backup and convert phase and the restore. But I would say the benefit of the DBMS file transfer method is you don't need staging space because it can do everything in one pass. The conversion happens as part of this process. So this is quite convenient, quite nice, but officially not supported with the PERL scripts anymore because there's a limitation for DBMS file transfer, 2 TB per file size. You would say now, hey, wait, my database is just 600 GB. You're free to use that. But believe me, in practical environments, when we go in the hundreds of terabyte databases, you rarely find databases with just files up to 2 TB. I've seen files up to 50 TB, one single file already. And then it doesn't help you. So you decide, and we follow here the standard approach with backup, restore, convert. So next step is we need to configure the process. And the process gets configured by editing the XTT properties file. This defines now all the pointers, all the definitions for our process. And this is the part you have to do here. The table spaces in our example, you see we have just simply 2 table spaces, TBS1 and TBS2. Platform ID, you remember, $, transportable platform tells you the platform ID for your platform, and it's the platform of the source environment here. Then we need the locations where we write the backups to. And ideally, this is a mount, a shared mount from both sides. It can be a ZFS file system, an NFS, whatever is convenient and works in your environment. And we need also to define the destination data file location. This is where we finally, after conversion, restore into. Here, also the ASM home and the ASM SID, and parallel. The default, I think, is just 2. So if you have compute power, then increase that and also roll forward in parallel. Here 2 is the default. So these things need to be defined. And once you are done with that, you make this file and the entire package you download it available on both sites. So both need the exact same files in the exact same subdirectory. Then we have the staging space here. So it's mounted on both sides, it's accessible from my source, the red environment with the table spaces and the target. And I call XTD driver PL -- backup. And this realizes now RMAN is smart. Hey, there's no backup yet for our purpose. So let's do a level 0 backup. That will be written into the staging space. And be aware, this may take a while. Project, I remember we had I would say 120, 130 terabyte database. This initial level 0 backup took 6 days to a relatively slow ZFS storage on a very stretched and stressed network. But hey, it's no interruption on production. Once the level 0 backup is completed, the process writes also a file called rest.txt, which has some pointers for the restore process. We need to copy that to the target environment. And once it's there, we can now trigger the conversion and restore process. So XTD driver PL -- restore will now take the level 0 and convert it and then restore it into the final destination here in plus data in my ASM, following the XTD properties file from before. Initial level 0 is done. Now I do my first level 1 backup. I call the exact same command, XTD driver PL -- backup, writes the level 1s now, the incremental backups into the staging space and copy over the rest.txt again. Once this is done, I call XTD driver PL -- restore. And now the level 1 backups will be converted and restored, which means they get merged into the existing level 0 ones. That merge is really important and a pretty cool technology here. I repeat that because that process, and you will see this in a custom example in a few minutes, should be repeated several times. The more frequent you repeat it, the smaller your level 1 backups get, and the quicker they get restored, converted, merged into the target. So I repeat that process here maybe once, twice, copy the rest.txt, and then call XTD driver PL -- restore, and I can do this as often as needed. Then final stage. Now downtime starts because now I have to set my data table spaces read-only. Table spaces are read-only, application is stopped, of course. Or maybe you can switch the application into a read-only mode as well. Final incremental backup will be written into the staging space, rest.txt copied over again, and then XTD driver PL -- restore. And so it will be restored, converted, merged in one pass. It's there, all is good. And final step will be now, we have to move also what's in our dictionaries. So what else is there? We have user definitions, views, privileges, synonyms, all these things, PL SQL code. This needs to be moved over as well because it's not in our data table spaces and we can't over system and sysaux table spaces. In this case, we call data pump. Ideally on a network link, that's the easiest way. So over the network link, now we pull everything over. Full equals yes, and transportable equals always are the keywords for the full transportable export import. And data pump will now rebuild the entire dictionary structure, but also plug in the table spaces. And you see this transport data files. You see the table space pointers to my locations in ASM, and then it will be plugged in as well. And all the information from what's in these table spaces will be imported too. Pretty smooth process. Final step, we recommend that. It's not mandatory, but if the time allows, do an RMAN validation to make sure every file is really in good shape. Everything is there because we haven't read the data yet. And then once this is done, I can set my source environment again, read-write if I need to. Otherwise, I shut it down at this point. You decide, and that's it. And with this, I would like hand over now to Daniel because Daniel will show you the entire thing in action in a demo.
Thanks, Mike. That's interesting, but we all know that things always works in PowerPoint. So let's see the PERL scripts in real life because it's demo time. I have a 12102 PDB that I want to migrate directly into a 19C CDB using the PERL scripts with RMAN Incremental Backups and full transportable export import. I'm connected here to the source host. I connect to the database. And I see that block change tracking is not enabled. So let's do that to speed up the incremental backups. Okay, I can also see that it's a 12102 database. I head into the sales PDB. And you can see that in my schema SH, I have a few objects. Roughly around 500 megabytes, so this is a toy database. All my objects or segments are stored in the user's tablespace. Now on the target system, I connect to the container database, and it's running 19.8. I create a new pluggable database that I call sales. And I verify that my target PDB does not have a tablespace called users. It's an encrypted PDB, so I need to do some massage on the TDE part to ensure that it's ready to receive an encrypted database. I create a TDE master key, and now it's time to configure the PERL scripts. I'm on the source host, and I have a zip file containing the PERL scripts. Simply go to my Oracle support to this MOS node where you can download the PERL scripts. Do an unzip and you will find all the magic in there. xttt.properties, this is where I do all the configurations. I want to transport the user's tablespace. Platform ID 13, that's Oracle Linux. I need to define some working locations on the source and target host, where in ASM that I want to put the data files, details about the ASM instance, some parallel options, and how I can connect to the target host to move the files as part of the process, and also connect strings to the source and target database. Then I copy all the files to the target host as well, because I need the scripts on the target system too. Now it's time to perform the initial level 1 image file backup. I set a working location and I call the PERL scripts with the -- backup option. It'll detect that no backup has been created before, so it'll start doing a level 0 backup. At the end, I need to copy the result file res.txt to the target system. It contains metadata about how far in the progress the PERL scripts are. Then I connect to the target system. And I use the PERL scripts again, but this time with the -- restore option. It'll see that nothing has been done on the target system, and it'll start to restore the files onto the target host. I can verify that in ASM. I can see here that the data file has been restored into the right directory. So now we can start working on the incremental backups. Remember, there's no downtime yet, the source database is still online. So on the source system, I just call the PERL scripts again with the backup option. It'll detect how far in the process it is and start an incremental backup, because we already did the level 0. When that completes, I copy the result file again to the target system. And then I can put that level 1 incremental backup on top of my data files. I just call the PERL scripts with the restore option. Now, downtime window starts and we can perform our final incremental backup. On the source system, I connect to the database and into my sales PDB. And I create a new table called cost2 so that we can verify that no data is lost as part of the migration. And now I set the user's tablespace read-only. We now have downtime. Then I call the PERL scripts with the backup option to perform the final level 1 incremental backup. It gives me a warning that the user's tablespace is read-only, but that's intentional, so we don't have to worry about it. In the end, I again copy the result file to the target system. And then I can do the final restore on my target database. And there we have it. Now we can import the metadata. We'll do that over a database link using full transportable export import. I connect to the database into my sales PDB, and now I create a directory that can be used by Datapump and a database link that points back to my source PDB. And I just verify that it works. This is my Datapump parameter file. Network link specifies the database link pointing back to the source PDB. It's a full transportable export import. I've excluded some various options, statistics and the sysuser, information about the directory and the log file, and which data files that I want to transport. And then I call Datapump import, specify the parameter file, and because it is an encrypted PDB, I also choose to input the TD keystore password manually. And the very first part of the process is the tablespace plugging. Now the data files are being recognized by the database, and after that, all the metadata is imported. It took around 3 minutes for this little database. So let's verify that everything works and no data is lost in the migration. I connect to my new sales database as SH, and I query user tables to ensure that my cost-to table exists in the target database as well. It does, so there is no data loss. Everything has been transported. What about DataGuard? What if your target database must be protected by DataGuard before you go live? Do you have to build a brand new standby database as part of the maintenance window that can severely prolong it? Or is there another option? And there is when you use this method. If you have a source database and on your target system, you have your primary database and you already prepare a standby database, you ensure that it works and you set up redo transport and redo apply. On your source database, you have the blue data files, and you want those to be restored onto the primary database and onto the future standby database as well. So you need to repeat the process with the PERL scripts to both the primary and the standby database. And it's very important that you restore and recover the data files to the exact same SCN on the primary and on the standby database. The two SCNs of each individual data files has to match, otherwise the process will fail. Now that you have the exact same data files on both locations, you can use Datapump to import the metadata into the primary database. It'll do the plugin of the tablespaces, and those commands then propagate via redo to the standby database, where it'll also plug in the data files there. And that way you can prepare the standby database in advance and do a lot of the heavy lifting so that you don't have to wait for the standby database to be created as part of the maintenance window. There is a really good MOS node with a lot of details, step-by-step instructions on how to do that as part of a full transportable export import. So if this is relevant to you, visit the MOS node and get all the goodies. Now over to Roy, who will take you through a very interesting customer case with a huge database.
So now you've seen that while transportable tablespaces can be a bit complicated to use, it can also be an effective way of reducing downtime for a cross-Endian migration when you can use those incremental backups. But let's talk about just how effective it can be with a real-life case study. So this situation was migrating a 230 terabyte database for a health insurance customer. We worked with a company called Centric Consulting, who is an Oracle Platinum partner, very skilled at database migrations and upgrades. The project was to take that 230 terabyte database, which was originally on an IBM P series running AIX 5.3, and move it to Exadata. So they needed the higher power Exadata, the better performance, to handle the growth that they were experiencing both in customer base and in processing requirements. This database was not just a data warehouse, but also an operational data store, and it even had some development environments in it. So it was a very active database, crucial to the day-to-day operation of the company. So minimizing downtime was extremely important. And here we're moving this 230 terabyte database from a big Endian platform, AIX, to a little Endian platform in Exadata. The biggest constraint was the database itself, because not only was it large, I think 230 terabytes was big by any measure back in 2017, but it was also very active, generating over 25 terabytes of redo per day. And that was a limitation right off the bat, because the initial attempt to use GoldenGate, it couldn't keep up because that old IBM P series was already overloaded with the day-to-day operations of the database. They couldn't then handle migrating another 25 terabytes of redo, capturing that with GoldenGate on that old server. The Exadata was perfectly capable of ingesting it, but the old server was not capable of capturing it. So that's why we had to go to a different technique, in this case, transportable tablespaces. They also were using the original, well, not quite original, but version 2 scripts for this RMAN cross-platform transportable with incremental backups. And those scripts back in 2017 had some limitations that had to be worked around, and will give you a sense of how much more sophisticated the process is now with version 4 of the scripts. So first of all, originally they had single-threaded file transfer. So they could use parallel in the XTT properties, but the number of data files that would be moved was still limited. In fact, the transfer was so slow that with just one job running, it was only moving 100 megabytes per second throughput, which is, as you can gather, just under a gigabit per second throughput. That's not nearly enough for 230 terabyte database. It was going to take nearly a month just to instantiate the level 0 backups. So that was clearly a problem. And that was worked around by breaking the transfer jobs up into 40 different directories. So we took the 530 or so table spaces, and these were small file table spaces, by the way. So multiply the table spaces by a much larger number of data files. Spread those across 40 directories and have 40 parallel jobs running, each with parallel 2 within the job. And that meant we could move 80 files at a time. And that significantly increased the throughput from 100 megabytes per second to 800 megabytes per second. So now we were able to reduce the time to instantiate that initial level 0 backup from 27 days down to 6 days. So that's a much more acceptable period for that initial instantiation. Additional considerations, well, in this case, this database was really exceptionally active. Not only was it generating 25 terabytes of redo per day, but there were new tablespace data files getting created, and in some cases, new tablespaces getting created. So during that 6-day window for instantiating a level 0 backup, we had to take into account the fact that a new tablespace might appear before the end of that window. So there were cross-checks in place to make sure that any new table spaces got picked up by that transfer process. So there was a lot of custom automation added here. The data pump import parameter file was optimized for the plugin steps so that it could have the transport data files added after the fact if new table spaces were created. And then there was a lot of load balancing done in the Exadata for the RMAN convert. So this was a half-rack Exadata going across 4 nodes. We were able to do an RMAN convert of 230 terabytes in just over 10 hours for the initial instantiation. So here's the environment. We're starting with that legacy IBM P series, going to an Exadata with disaster recovery. So there was another Exadata in a different data center that was being set up as a standby. So that complicates it just a little bit. We're not just building the new database, but also then building the standby off of that database, which will be our disaster recovery. But that becomes very important as part of the final go live event. So all of this was accomplished in one phase. Not only are we moving cross-Endian, cross-platform AIX to Linux, but going 11.203 to 12.102, moving from single instance to a rack database, moving from a file system on the P series into ASM on the Exadata, doing it with 230 terabytes. And oh, by the way, changing from the original character set to a new character set that was a binary superset of the source. In other words, the new character set had the Euro character where the original one didn't. That's a very special case where Transportable Tablespaces was able to go to that new character set. So was it successful? Absolutely. And this is a shot from the spreadsheet that was used to track the timing of the project. And let me explain what's going on here. That yellow bar at the top, that's the initial instantiation phase where we're taking the level 0 backup, moving all of those data files, 230 terabytes, to the new server, running the RMAN convert on 230 terabytes, making sure that the standby is going to be in place. Then the red and blue boxes are taking and applying the incremental backups. And what you see there is that each incremental backup gets successively smaller and smaller as time goes on. So after the initial phase of instantiation, we have a couple of days of taking an incremental backup, shipping it to the target site, doing the RMAN convert, and applying it on the Exadata side. We do this a number of times till we get that backup, convert, apply window as small as possible. And at that point, then we get to that final downtime window, which was only 16 hours. Now, 16 hours may be a lot of downtime for some migrations, but when you consider all the work that's going on here, the cross-platform, going to a new version, changing character set, single instance to rack, all of that going on in one migration, 16 hours was really a victory in this case. So what did we learn about this? Well, the first thing is make sure you have the latest version of the PERL scripts. You saw some of the limitations of version 2. Version 4 eliminates all those limitations where we have more parallelism. There's a lot more automation involved. They're much more efficient. But you should still plan for the unexpected to happen. In this case, the customer was aware that they had the odd condition of perhaps creating a new table space in the middle of a migration. Does that happen in your environment? Do you know whether that happens or not? That's the kind of thing you need to be able to plan for that might be very specific to your environment. And then customize that process for your super large databases because you want that preparation phase to be as short as possible. If you have to jump through a few hoops to make that initial instantiation faster, that will be to your benefit because it will mean fewer incremental backups that take a lot less time. But overall, this is a great technique that we've been seeing at a lot of customers that have these 100+ terabyte databases or now getting even to petabyte databases where you can minimize the downtime and get it down from days to hours or even maybe in some cases tens of minutes.
This was a pretty cool example, wasn't it? So thanks, Roy. But at this point, we want to push the limits still a little bit and briefly discuss a customer project where approximately 1,500 databases should be migrated to an ExaCC environment. And in this case, we use a zero data loss recovery appliance. So the strategic overview is we have the AIX platform on the left side here on the slide. Then we do incremental backups to the recovery appliance anyway. And from there, we restore and recover and run the transport and rebuild the metadata to the ExaCC. That's the overview. And here, the zero data loss recovery appliance adds really a very cool piece to that entire story because it automates a lot of things. Especially here in this case, we also run not only one incremental backup, so we run several levels. Again, by increasing the frequency, we decrease the time it takes to restore and merge at the end. And finally, when we are done, then we do the transportable tablespace move and the metadata information gets moved over as well. So the recovery appliance in our step here, we have special adopted PERL scripts. So our team here owning the PERL scripts did a fantastic job in adopting these scripts and making it applicable to the recovery appliance. A special version can be downloaded, db mig use ra.pl. So use the recovery appliance, and these are the customized PERL scripts. In addition, we need also a special version of the lib recovery appliance, the libra.so. And please, as a general rule, when you have a recovery appliance, always make sure you have the newest version. That lib doesn't go only on the recovery appliance, it has to be also on the ExaCC and on the source IBM machines, because this allows us to interact with the PERL scripts. Then we download the MIG use recovery appliance scripts, and this includes also the XTD properties file. This is again another MOS node, and we deploy that package now to the recovery appliance and to the ExaCC. This is the special version here. It's a bit shorter actually than the previous one. So we point to the libra.so. So to the library, we copied in on the recovery appliance and the machines. We run in parallel with 16 files. The table spaces, this needs to be adjusted per database here in this case. And we always use the same location, source platform ID. In this case, it's AIX, so it's 2. The destination platform will always be figured out by RMAN. If you ever wondered why we only need to specify the source, destination is figured out by RMAN, a DBID and a retry count. That's very short. So what we do, same as before, the level 0 backups get triggered when we call PERL dbmig use RA -- restore, and then afterwards it will be converted and also wrote or written to the final destination with -- recover. That's it. We repeat the same thing now with the level 1 backup, same call, restore, recover. And then once this is done, the second part comes in. And this, by the way, is the team lead who ran and drove that project, Sona Toraman from Metronome here. And when you download a full slide deck, our big slide deck, you find the entire customer case there documented. So transportable tablespaces to ExaCC. And here we customized transportable tablespace scripts to a fully automated solution. And I won't go into details here, but just that you see, if you have a recovery appliance or if you consider using one because you have really a large migration project of hundreds and thousands of systems, and the recovery appliance can help you a lot automating this process of running the incremental backups, rolling them forward, doing the conversion, everything handled by the recovery appliance here. And you just need these special adopted PERL scripts to put everything in place on the destination side. That's it. And with this, we have some tiny little features to add here, transport features, new and advanced features to just finalize that part here of the presentation. First of all, we have a test mode for transportable tablespaces. So thanks to the data pump team for adding this, it's actually new in 19C. When you use transportable tablespaces, sometimes you face the situation that you don't have a proper test system. The database, the source database, is so huge that you don't have the 2 petabytes on an equal test system. We would recommend that you build up at least like a Q&A system with the same layout and just smaller files so you can see if the process works. But even if that is not possible, and your files are really big, you still face the issue at some point that you need to put your table spaces on the production side into read-only mode in order to run the transportable steps. And that means downtime. So when I switch all your table spaces on your 2 petabyte system to read-only, that is essential downtime. So we added this read-only mode override switch, I would call it, and we called it test mode. So you can add to your data pump par file the TTS closer check. By default, it's on, but we switch it to test mode. And this allows you now running the transportable tablespace export. And especially when you have partitions and subpartitions, this may take a little while. So you get an idea how long this will take. And you can't use the files generated by that, but you can get a really precise idea how long that step will take. without the need to take your source table spaces into read-only mode. Another additional parameter we introduced also with 19C is keep the table spaces read-only. By default, as my mates have explained already here, when you plug in into your target database, automatically the table spaces are read-write. But this is not always wanted. We had cases where the customer wanted to share the table space between source and target for a while until all the steps are finished, because the application could still run in read-only mode on the source. And this way, read-only on both sides, you can still keep the table space plugged into the source. And if something goes wrong, you just destroy the target and everything is still available on source. But since, I can't remember, I think 12.102, automatically a table space plugged in, once the plugin process is finished, the metadata export for the table space contents has been finished, the table space automatically went into read-write. If that is not wanted, you use transportable keep read-only. And this now allows table spaces to be plugged in without going automatically into read-write. And you see this in the second box here, TTS table space is kept in read-only until you switch it to read-write.
Thanks, Mike. Now let's talk about the next migration technique, which is GoldenGate. And this one is the only real zero downtime migration method we have here. Let's see the concept. First, you have your source database. Then you have GoldenGate, which can be GoldenGate microservice that you can deliver using OCI Marketplace. And you have your target database. The first thing you need to set up is the extract process. So you configure the extract process and you will collect all the operations that happens in your source system in a file. Now you do the initial load on the target system, meaning you create a dump file or can be a backup on the source system. You move and you restore it on the target system. You note down the SCN for that load that you did, and then you configure Replicate to start from this SCN. And now what you have is all the operations flowing and being applied on the target system that happens on the source. Finally, you can simply move your application from the source system to the target system, and you can officially reverse the replication. The benefits of GoldenGate is that this is the only truly zero downtime method, as I mentioned in the beginning. Also, it's extremely flexible because you can do cross-version, you can do cross architecture, you can do cross-Endianness, you can do almost cross everything. You can also use this method to go from a non-multi-tenant to multi-tenant architecture if you want. We also recommend you to test the target environment before they go live. You can do this using Flashback database, and this is all detailed in this Moz note. Basically, what you can do here is you can stop the replicate process in the target environment. You create a GRP there, a guaranteed restore point. Then you test this target environment. After you're done with your testing, you just flash back your database to that GRP and you start back the replicate process. So you must have SQL connectivity between the two databases. However, if you don't have it, you can use GoldenGate hubs to do like a proxy of these files that are being shipped from the source environment to the target environment. We also recommend you to compress the trail files to reduce some of the network traffic. And here is in this example, if you have a 10 terabyte redo, you can reduce it to maybe 400 gigabytes to 1 terabyte trail file size. If you use data pump as your initial load method, just don't forget that the full database export will not contain everything. So, for example, you need to recreate the pub synonyms and also the database links you had. Also, if you want to ship the AWR reports you had in your previous systems, or the SQL plan baselines, the SQL profiles, or SQL practice you have specific procedures to export this information from your metadata. You can also encrypt the trail files to have better security while you are doing this in-transit migration. GoldenGate requires database minimal supplemental loading, but this does not impose a significant overhead in your system. If you check, for example, the logical standby database, you also need supplemental loading there, but as the extract process of GoldenGate, it takes place in source system, while in a logical standby, it takes place in the target system, the supplemental loading that you need in the GoldenGate is much, much lower than what you would need in a logical standby. The target database, when you use GoldenGate, must be in the equal or higher time zone format, okay? You can check it using a select star from time zone file. If you are moving from a source system which is 11.2 or 12C and newer, there are some specific bugs that you need to apply before starting, so don't forget to check the MOS notes for any specific bug so you don't face them during your hepcat or extract process. Also, we recommend you to enable DDL replication in your GoldenGate process, especially if you have an application that truncates the tables a lot. Remember that a truncate is not a DML, it's a DDL. And also regarding sequences, for migrations like lift and shift, I usually recommend the customers to replicate the sequence separately after the migration of the GoldenGate. That way, when they go to the switching over in the new database, the sequences are already at an acceptable level. So you might be asking, can I use GoldenGate in my database? There are some views in the Oracle dictionary that can help you. First is DBA GoldenGate support mode. This view has all the objects you have in your dictionary, and you have this support mode, which will tell you if that table or if that object is supported or not by GoldenGate. So you see here, we have some examples of the support mode like ID key or full. So let's see what they represent. If you have support mode full, means all good. Object is fully supported for GoldenGate. If you have it as ID key or PERL cycle, it might be that some of the columns are replicated only, not all of them, or that you need to configure procedural supplemental logging for that specific object in your source database. However, if you have in that column something like internal or like none, this is not good. This means that the table is not supported by GoldenGate, either because they are internal tables like mview logs or like some objects that has some domain indexes on it, or simply because the table is not supported. So if you want to understand why a given object is not supported, before 19C, this support mode column has those values that I just explained, and you will need to do some research and understand why that table is not supported. However, since 21C, there is a new column called description, which will tell you exactly the reasons why that table is not supported. In this example here, we see that for ID key support mode, it explains you why it's not supported. However, for full, you don't have any explanation, because remember that when you have a full, means that it's all good, this table or this object is fully supported. For optimal performance, we always recommend that all tables have primary keys or unit keys, or at least a unit index on it. The reason for that is when GoldenGate replicate a delete or an update statement, it won't need to do a full table scan all the time that it performs those operations. There is also another view in the dictionary called DBA GoldenGate not unique, which will tell you all the tables that has non-unique columns. There are some applications that maintains uniqueness inside of it. So it won't have any object created in the database to tell Oracle that that column is unique, like a constraint or a unique index. However, if you know that because of some application logic, that table has a unique column. You can specify in your abstract configuration this key columns clause, and then specify which columns are unique for that given table. That way, when GoldenGate process, it will know that this column is unique and will do some different behavior on it. Also, we have a health check for GoldenGate, which works similar to AWR, but for GoldenGate. With this, you can check all the prereqs, you can get all the database characteristics. Also, you can get a lot of statistics and metrics, like what is the throughput that GoldenGate is doing in your environment. To enable this health check, what you need to do is you need to install some objects in your database before using this script, the OGGHC for health check _ install.cycle. Then you can run the health check using OGGHC _ run. And finally, if you want to delete all the objects later, you can run the OGGHC _ run install. To get those three scripts, you can open the GoldenGate microservices architecture and find the objects in this folder location. This NN here after the Oracle name depends on the source system. So it can be Oracle 10, Oracle 11, Oracle 12, and so forth. Now Daniel will cover some more features of the GoldenGate migration.
Thanks, Rodrigo. But what about upgrade? That's not a problem with Oracle GoldenGate. Oracle GoldenGate is so flexible that you can extract your changes from one release and migrate or replicate your changes into a different release. You can go to a higher release or to a lower release. And even if you have a very old database that runs on a very old version of Oracle database, you can use multiple instances of Oracle GoldenGate of various versions and then eventually replicate into a newer released Oracle database. What about PDB conversion? Again, here the flexibility of data pump can truly be a help to you because you can replicate your changes into any architecture. So if you have a non-CDB database, you can replicate directly into a PDB, thus avoiding the downtime it normally takes to convert the database into a PDB. And a little later on, when we will talk about fallback options, again, here you can replicate your changes from a PDB into a non-CDB database. Can you offload the work from the source database? Oracle GoldenGate works by mining the redo logs and extracting the changes that can then be replicated. That mining of the redo logs can be resource intensive. Can you offload that work? And yes, you can. In Oracle GoldenGate, there is the concept of a downstream database. It works like this. We have the source database where users are connected. We have the target database where we want to replicate to, and in between we have the GoldenGate hub. Now let's introduce a downstream database. It can be a brand new empty database. It doesn't have to be a copy of your production database. No, just an empty database. And you configure it as a downstream database. In your source database, you configure a log archive destination, just like a standby database. And now redo logs are being shipped from the source database to the mining database. In the downstream database, Oracle GoldenGate will inspect the redo logs and extract the changes that are to be replicated. And those changes are sent to the target database. So you can add an additional component, the downstream database, and thus take some of the heavy lifting away from the source database and put it into the downstream database. You still need to have SQLnet connectivity from the GoldenGate hub and directly into the source database. GoldenGate needs that in order to extract certain metadata. What if your target database must be protected by DataGuard? With Oracle GoldenGate, you can start to create the DataGuard before go live, before the downtime window. You do that after you have created the initial load when the target database is receiving changes from GoldenGate. It works like this. The users are connected to the source database, so there is no downtime yet. You have created the initial version of the target database. You have populated it with an initial load, and you can then create a standby database. You can build a copy of what will become the future target primary database. Then, as the changes are being replicated into the future primary database, they will then go to the future standby database via regular redo apply. So this way you can prepare your data guard setup. You can even test that switchover and so works, so that you are protected from the very second that you do the switchover and the users are connected to the target database. Then you can optionally reverse the GoldenGate replication so that the changes are now being sent back to your source environment and changes are going with redo to your standby database. Your target database must have a valid backup before go live. That is the case where you will not allow the users to use your new target database until you have a good backup. Well, again, here with GoldenGate, that is easy because as soon as you have created the initial load with Datapump or RMAN, you can create the backup and ensure that it works. So in this case here, the users are still connected to the source database. It's before the downtime happens, and you have created the initial load into the target database. Now the changes are being replicated with GoldenGate into the target database, but at the same time, you're starting your level 0 backup of the target database. You can also verify that the backup works. You can try to restore it into your DR site. And then when you are ready, when the level 0 has completed, you can complete the migration and allow the users to connect to your target database. What about RAC? What if your target database must be a RAC database? That's not a problem because Oracle GoldenGate can connect to a single instance database or a RAC database. It just doesn't care. All it needs is a SQLnet connection to the source and target database. Whether it's RAC underneath, that doesn't matter. And finally, the fallback plans. This is where GoldenGate really has something special to offer, because there are some excellent fallback capabilities when you're using GoldenGate. In this situation, when the users have connected to the target database, the migration has completed, you can reverse the replication so that the changes are now being sent from the new target database back to the source environment. So if you find out that there is a critical problem and you would like to go back to the source environment could be running on old hardware, a previous version, and a different architecture, for instance, a non-CDB. Since we are replicating the changes back to the source database, we can simply just switch the users back to the source database, and we have performed our fallback with no data loss. Another option is to use bidirectional replication, where users are connected to both databases at the same time and changes are being sent both ways. This has the benefit that you can do a phased migration. You can send the workload to the new target database in batches, so you can see if it works, move a few users, test the new system, does it work, move over more users, until you are confident that the new system truly works. If something happens, simply just switch the users back to the source environment and you are good to go. Having bidirectional replication is really cool for fallback purposes, but it does require some additional advanced configuration, so you should only do this if absolutely necessary.
Okay, time for a quick summary and wrap up. The number one question we get from customers when it comes to migrating a database is, well, what's the best technique for me to use? And that's an understandable question, but it's not an easy one to answer because the right tool for the job very much depends on the characteristics of your environment, your database, your network architecture, where your data centers are placed, and so on. So the main thing to remember when you're choosing a technique is that when you think about all these technologies we've talked about, RMAN, DataGuard, Transportable Tablespaces, GoldenGate, Full Transportable, is that there's always going to be a trade-off between simplicity and downtime. And sometimes there's a trade-off of license cost as well. If you want the minimum downtime possible, then you have to accept a bit more complexity, maybe some extra license cost if you want to get something like GoldenGate involved. If you want the simplest approach, then you're going to have to accept a little extra downtime. Backup and restore is very simple, but for a large database, it could take quite a while. So whatever your environment, whatever your needs, we do have the right tool for the job, but you have to make those trade-offs for yourself. And speaking of technologies, I do want to remind you that we have that March 3rd webcast coming up about Data Pump. We didn't go into Data Pump very deeply here, except to the extent that it's the interface for transportable tablespaces. But when it comes to Data Pump in general, that's your Swiss Army knife, do-it-all migration tool. We're going to go into great depth in March about new features, internals, and maybe even some features that have been around for a long time that you didn't even know about. So we hope you join us in March. And now I'm going to hand you off to Mike for a final few words.
You made it. Thanks for staying with us. Just a few final comments. Their seminars are all uploaded either to our YouTube channel or the Oracle platform, and you can easily access them via our blogs. So mikedietrich.de.com/videos, dohdatabase.com/webinars, or dbarj.com.br/webinars. When the videos are on YouTube, and we try to upload all of them to YouTube now, to our YouTube channel, you find also a description and pointers below the video. So for instance, if you're only interested in how to use DataGuard as a migration vehicle, you just can click and it will direct you automatically to the right place in the video. We have 12 seminars, I think, uploaded. Once this one is going live as well, in a few days after this gets broadcasted, you will find it there as well. And feel free to browse through them. Altogether, we have now more than 20 hours of deep technical content. No marketing speeches, just technical, hopefully helpful content regarding upgrades, migrations, consolidation, move to the cloud, performance testing, and so much more. And there's more to come. But before, you should spend a minute to visit our YouTube channel as well, and feel free to follow the channel, subscribe to it. Again, no marketing. Actually, plus 100 videos. I think we have more than 200 videos now in our YouTube channel, and every 2 days we release a new video. No marketing, no buzzwords, just tech and things we tried out by ourselves. Nothing we heard from somebody, always just things we tried out by ourselves. So feel free to subscribe to our YouTube channel if you haven't done already. And with that, final hint to our blogs. You have seen the blog links already. The webinars on the blog and YouTube channel. And finally, our next webinar will be in March. Now it's December, so it's a little while to go until March, but we need a rest. You need a rest. We wish you happy holidays, a very good start into 2022. And then we hope to see you soon again, and feel free to sign up and then tune in on March the 3rd to our next seminar, the Data Pump Deep Dive with Development. A lot of D, like Dietrich, and I say goodbye, my colleagues say goodbye. Thank you again, and stay safe, take care, and see you all next year again. And thanks for coming to our seminars. Thank you, and goodbye.